I uploaded a video yesterday talking about bad habits in C++. And obviously people were shitting on the video. I love it. I was expecting this to happen, and it did happen. Okay, this video right now is sitting at about 81% likes because it was a video about noob habits in C++. And the comments were really cool to read through. We read through them earlier today. Can't be fixed with STD Atomic or Auto R. Can't this be fixed with? And you know, because there's a lot of opinions, Cakez quickly becoming my favorite programming YouTuber. I feel like I actually relate to him. Love this video, trying out Zig. The frustrations are real and raw. Love watching these videos. Take care if you're trying to learn anything though. Shut the fuck up. Shut the fuck up, bitch. Who was this guy? Okay. Anyways, so I knew this was gonna happen, and now we're going to watch someone who is smart explain the things that I can't explain. We're gonna watch this guy explain RAII and explain to us why it's good or bad.
Stack Overflow says you must use smart pointers. The handmade hero codebase has no smart pointers. How can this be?
Oh, can you hear this?
So roughly what I would say about that is, you can imagine, if you imagine like a programmer's life cycle, you know, it looks something like the following.
Yeah.
So, you know, no one's like just born knowing how to program. It's something that you learn, and inside your brain, you learn to program in definitely in stages, right? And the stages are pretty...
Before he continues, I think programming ultimately is just another tool to solve problems. So if you are getting better at programming, you're effectively just getting better at solving problems using the tools you're given. Whether that is tools from the standard library or whether that is tools from C, from Go, from Rust, ultimately it doesn't really matter. You learn to use the tools. Maybe you're constrained, maybe you're free to use whatever you want to, but it's ultimately about just solving problems, having an issue and then solving that. So, but obviously there's a lot of language features and right ways and wrong ways to do this. Like people come up with this stuff. So let's see.
Consistent, I think.
Oh, what's this dude's name? So this is Handmade Hero. This is Muratori. He's been programming for effectively very long time, essentially. I don't know how long even, but essentially he's been in the field for a very long time, and he's worked on different games, helped Jonathan Blow make games for him, and he's also been programming some other stuff. I don't know exactly what he's been programming, but he's very knowledgeable when it comes to C and C++ and how the operating system works, and essentially the compiler and C and C++.
I won't try to do them all here, but at some point when you go through these stages, you get to stage N, and stage N is, I guess, what I would call the individual element thinking, right?
Mm-hmm. Whatever that is.
Individual element thinking is when you think of each specific piece of data in your code as having its own lifetime. So for example, if you're going to create, like in our code, we have entities.
Yeah.
You think about every entity as getting like a new or a malloc, or the first time you create it, and then you think of it having like an endpoint that's its own, and that's where you call like delete, or the garbage collector cleans it up, or a smart pointer in this case automatically deletes it because someone else is owning it or whatever, right? Yeah. And these architectures tend to look like they have like RAII style. They have like literally like thousands or millions of new delete or malloc free. They have...
I mean, it depends how you do it, but if you're using smart pointers, yes. So let's say you create a projectile, you turn that into a smart pointer projectile. I don't know why you would do that, but essentially that's how you do it. And then after the projectile is done doing its damage, it's going to clean up after itself. And then you don't have to worry about freeing or allocating the projectile itself, because it's all done using the smart pointer, and you just use the projectile, essentially.
Of giant nests of pointers from things to other things, right? And this is just some place you get to. Now, a lot of people never move past this point. Sometimes they don't move past this point because they never program in a language that doesn't have a garbage collector. If you're always in a language with a garbage collector, you probably don't think about these things very much. And to the extent that you ever actually...
No, you don't. Oftentimes you don't. You know that it's going to be cleaned up, you use it, and then you don't even have to free it, you just use it, exactly. Like, for example, but you do. So for example, in Unity, have you guys ever heard about object pooling, where it's often used for projectiles? And correct me if I'm wrong here, but you have an object pool for projectiles, and then whenever you create a new projectile, you create it in that pool. And whenever the projectile ultimately dies, the pool is still there. There's a slot in the pool for a new projectile that opens up. And so if you create a new projectile, it is then taken from the pool before maybe taking more data from somewhere else, because the pool is not exhausted yet. And the pool is essentially working as like a fixed array where it gets some holes, or maybe it's packed, and you ultimately just, you use this pool, which is a fixed memory slot, essentially. I don't know exactly if that's how it is in Unity, but that's how it works. Yes.
It will only be because you're trying to do something performance-oriented, and you have to start pretending you're actually...
And so you do think about the lifetime of objects, especially when you take a look at the inspector, and you see that an object is still alive, even though you're no longer using it. And then you're like, oh shit, I didn't clean this object up. That happens in Unity. Now, I don't know about other games, especially where you don't have an editor like Unity to help you out.
In your own memory, even though...
Can I set to 1.25 speed? Is he too fast? Yeah, sure, I can.
And most people who write games in garbage collected languages have had to do this, but if you're just doing things that are not like performance critical in that way, you wouldn't know... You'd never have to get past here. Someone on the Twitch said try catch, and I'll put that in here as well. So this is individual element thinking. It's something everyone does. I've definitely had a period where I was programming that in. So I don't want to say that people who do it are stupid or something, because everyone does it. Like there's no not doing it. Mm-hmm. I don't know anyone who ever successfully avoided this stage of thinking. The stage is stupid, meaning the code you write will be stupid, but you are not stupid because everyone does this at some point. The key is you have to get to n+1 at some point, which is group thinking. Right?
Okay, what does that mean?
And at group element thinking stages, this tends to be like large collections created, destroyed at the same time. You know, almost no...
So essentially, instead of... That would be the... Actually, but that's the pool of projectiles, the object pooling for Unity, where you have your projectile pool, arrays everything. Yeah, so an array of projectiles in Unity that are there all the time, and if a projectile dies in the pool, a slot opens up. Yeah, true. That is the n+1 then. Let's do this with Unity as an example, right? For my game, that would be normal arrays, and then having an array of fixed size for the projectiles, and if the array is too small, I need to make sure that the array is bigger. Yeah.
You know, very, very few new delete malloc.
Yeah, true. Because you're essentially, instead of turning every projectile into new delete, you're turning it into a pool new delete, essentially. Yeah.
Heavy use of scratch space.
Yeah. Yeah, that's the scratch space, right? The slot that opens up. True.
Typically, like hashes and reuse show up in here a lot.
Yeah, I don't have hashes. It's too complicated for me, but yeah, I guess you could. Yeah, true.
So,
I guess.
When you're talking about making this jump, when you
you
make this jump from n to n+1, so smart pointers live here.
Mm-hmm.
Right. So at the stage when you're still stuck thinking about individual pieces, all having their own lifetimes. The problem that you run into is that there's so many of these things. I mean, there's literally millions or even billions of them in a program. If you were to manually always be allocating and freeing all these things individually,
that's
you can
impossible.
see why people say, well, you've got to use smart pointers.
It's
because
impossible.
Otherwise you have to remember to always
Everything.
in two places. You declare the pointer, and then in the destructor, you have to add a delete manually. You can see why people think in their head smart pointer makes sense here, because it's a way of typing something. I can just look at one line that's the declaration of the pointer and know that it's going to get automatically freed.
I mean, so far he's only talking about the memory, right? And the argument under the video is that it's not only for memory, but it's also for file I/O. You can use RAI with the large collections too. Yeah, true, you can, potentially. But then you have a projectile in there that doesn't use a smart pointer. Or in the destructor, you don't free the element, but you basically say that this slot is now empty. It wouldn't be a deallocation. You can still do it, yes.
Now, the problem with this is you're really just patching over a flaw in your architecture. If two things are inextricably linked such that you have...
Yeah, the point is that it is optional, exactly. I think that's the point that he's trying to get to. You can use it, it's a tool, but you don't have to. So in the case of, let's keep the projectile array, I could keep the projectile array with holes, or whenever a slot opens up, I just move the last element of the projectile into that slot, and now I decrease the counter. Now I don't need to clean up anything. The cleanup happened because I moved the array, moved the elements over. That's really not something you do with RAII. You could program it that way using a destructor, right? It is possible, but it's not required. At this point, it becomes optional because now you don't have that many places where you do new and delete and you can track them better.
One get automatically freed when the other one is freed. In all but the very, very rarest of circumstances, what that means is those things should actually have a combined lifetime. And so what should actually happen is you should have just had one large pool that all of those things got created in that is just streaming into that pool so that you'd never have to do that. The pool gets freed together, so you...
So essentially, this is what it looks like when you do that in one pool. Obviously, it's not the best example, but it works for my game. And whenever I release my game, it becomes even more true than it is right now. Okay, guys? It is essentially happening like this. This is the entire... let's go here. This is where I allocate my memory. Bump allocation. It's very, very easy allocation. Very simple. Right? From a persistent storage. I'm bump allocating stuff here. And this is essentially the one place where I do that. And then essentially... at the very end of the lifetime of my program, past the loop, I would free stuff. And so you have one package where you do that and the other package where you delete. And then that's two places, essentially, instead of millions.
You don't need to have this rat's nest of pointers that you crawl through to make sure you eliminate everything. So that's what we do in Handmade Hero. We just have pools
You can
that get
do
freed
everything he said with C++ style, yes. But the point is that it's not a requirement anymore. It is optional. You are free to use it if that's what you like using, but it is not a requirement to tangle through a mess of pointers.
And everything that goes together goes in the pool. So I never have to sit around running around grabbing pointer, you know, which is what a smart pointer chains, that's what they do. One person gets freed, it crawls, the next person gets freed, crawls, the next person gets freed, right? It's extremely inefficient. So basically, when you move from here to here, smart pointers become irrelevant. You really don't need them anymore, right? Because you just don't have ownership concerns like the kind that you have here. You know, you could say ownership is a constant concern and mental overhead, right? Whereas here, like, ownership is obvious and, you know, trivial in 99% of cases. So basically, like, the thing to understand here is just that all of the advice you see online pretty much is for people thinking at this level, which is not where you want to be. Like, you're going to have to go through it at some point to understand what's going on, but your goal is to go from here to here. So advice like use smart pointers or the Rust borrow checker, like all that stuff, those are for people who are still not very good at programming, right? They're in a stage of architecture that is...
Ooh, he just shot a huge bullet. Ooh, this is going to upset a lot of people. Okay. Did you guys hear that? Not very good at programming. Ooh.
Limited
Shots
and not
fired.
appropriate for modern...
Oh, I can't wait for the downvotes. Let's go.
High-performance, well-architected code. It's an old way of thinking that just still is very prominent, and you're just seeing advice from that. Just the goal is to move on, right?
Okay.
So don't waste a lot of time learning all of this crap. You will have to go through this stage because everyone does eventually, but the goal is to get out of it as fast as you can.
Now the question is, what is +2? Okay, he advertised +2. I'm in +1 then.
I started to go to +1. What is +2?
Because 100% of all code written in this style sucks. There is
+2 actually writing a rocket science code?
No such thing as a good piece of code that has these ideas in it, because they are inherently inefficient, buggy, and over-architected, right? They're just not good.
We still don't have a point about the file I/O. Maybe he goes into this.
Like, actually, all of that crap
Scope issue, advice, paranoia, example. Okay.
Does that help?
So I might cut out some stuff if it doesn't relate to this. Okay, we're still gonna watch it, but I might cut it out for the video. We're interested in the points here, right? Essentially, I'm gonna sum this up really quickly. In the paranoia part, he's talking about how if you do a bunch of allocations, there can be you have to worry about not receiving the allocation. Therefore, you have to make sure that it's checked and handled properly. So you can, for example, raise an exception and then maybe try and catch that exception. And that is a lot of uncertainty in programs that is not needed if you do a ginormous block allocation. Because then, let's say at the very start of your program, you check that ginormous block. Do you have it? Yes. Do you not have it? Do the handling of the error there. And then the rest of your program is not subject to these paranoias, to the paranoia of not being able to allocate something. Then you need to be able to handle this case. Now you know that you will most likely receive something and you can just move on with your way and actually solve the problem that you're trying to solve, which is, let's say you make a projectile spawn, right? Let's keep it by the projectiles to summarize the paranoia part here. And now he's giving an example of RAII. Let's see.
A simple
here.
example of a step from n to n+1. So when I did the first version of the character animation system at RAD, I still was at stage n. And when I did the second edition, I moved to n+1. And the small step that I took at that time, the first step, was going, hey, if I have something like a character that has a certain number of bones and a certain number of meshes, right? What I used to do is I used to like new a character, and then I would new an array of bones, and I would new an array of meshes, and then the meshes would an array of vertices, right? All I did in that first step was I just said, oh, actually, when I create a character, I made this little thing that allowed me to say, here's all the memory that I need. I need this many meshes, this many bones, this many that, this many this for the character. And I just had a little utility function, utility struct I wrote that allowed me to like say, here's the stuff I need, go. And it would then try to allocate that entire block of memory that would be needed for the whole thing, and it would parcel it out. So then it would like set the pointers properly, automatically for me. That changed 5, 6, 7, 8 failure points into 1 failure point, which is way more reliable, right? Just that one step.
So what he's saying is, instead of having an array of bones where he called new, he would have a fixed sized array of bones that could potentially have some scratch space in it, where you have maybe 5 bones that are empty. That's essentially what I'm getting here. So essentially, instead of allocating the character and then allocating the bones and allocating the vertices, he has all of this already allocated, and the character just holds all of that data already. So it's 1 allocation instead of 7, essentially.
Makes it 8 times less likely that your code will fail, that you have a bug somewhere. And so it's just a case of just like start wherever you can. Anything you can do in your code base to do less, to make less calls or operations that can fail. Just try to start collapsing them together. And eventually, right, you get to the point where you've got like the typical thing that me and John Blow do now, and I think DICE does this too, so even like the EA games do this, is every frame you just have an arena for that frame of memory, and anything that's specific to the frame just goes in there.
Yeah.
This eliminates...
So it's basically called a transient storage. You give it a, let's say, let's throw some random number, 512 megabytes of space. That's transient for the frame. And then every single, I don't know, unit, enemy, projectile will use that memory that gets temporary, that needs a temporary. So for example, you probably need a new mesh, and then you load that mesh into this temporary memory, and that mesh then gets uploaded to the GPU and stays there for a while. And so in order to use temporary memory, you won't use a new allocation, you use your transient storage that is already allocated and freed for this frame. So you have 512 available for that. And then maybe you use 50 megabytes for the bones and the mesh and the vertices. You upload that to the GPU, you're done uploading. Obviously, this is a bad example in this case because you would probably do this in your own thread. But let's say it's all, you know, what do you call that? Sequential. Yeah, let's pretend it's all done sequentially, right? Which would be slow. Then, you know, you use that, you upload it, it's on the GPU, next frame it gets cleared, and now you have your 512 again. That's what it looks like these companies, and they do. Which I think is a good thing to do. And if you're worried about, for example, having scratch space, we can take a look at a very simple calculation of a 4x4 texture, right? So let's say you have a texture, 4K texture. you need to multiply that by itself, and then you get however many pixels are in that texture, and then you multiply that by, let's say, the color channels. That would be red, green, blue, and maybe an alpha channel, so multiplied by 4. This is however many bytes you have for this one particular texture. This is how many bytes you need. And so you could essentially divide that by 1,000. And now you have kilobytes. That is 67,000 kilobytes. And so that is quite a lot of memory. And now let's say you have a vector 2. We have 2 floats. That is 8 bytes per vector. And you allocate 1,000 of those. Now that is 8 kilobytes. And let's say you're only using half of these. You're wasting a space of 4 kilobytes. In relation to one 4K texture, that's ginormous. And so this is how I started thinking when I started using what he calls scratch space. You will have some wasted memory, but if you extrapolate that to a program that uses textures and models, the wasted space, maybe it adds up to 100 megabytes or 50 megabytes. While that's still a lot, it is not that much. Depends on the game, of course, but yeah, for my 2D game, and I'm pretty sure for most 2D and even 3D games, this won't be too much.
Steps I take now that are past that are I just design out the failure entirely. So what I do is I take arenas now and I stream into them, and if they can't get more memory to grow when they need to, all the code is usually written to handle when something comes back, it just produces a stub rather than a real one, and all the code still works. So that's the way I do those things now, and they literally can't fail. Even if you run out of memory in the middle of something that you don't even know what the size should be.
I just have an assertion, and then I make the memory bigger.
In the sense it doesn't crash. It just can't draw like the rest of the things.
Where's n+2?
Where's n+2, bruv?
This video was crap. The only argument against RAI was many small allocations are bad, but vector is RAI and encourages few big allocations. Yeah, but that's why we are watching it, and we got to the point where we stated that RAI is not bad. It's just a tool. And it is an optional tool when you're getting to this point. You can still use RAI. You don't have to use it because it's not a requirement anymore. It's just a tool. He said it's for bad programmers. Yeah, but that's why we are taking a look at the video and we are building our own opinion. We're not taking the opinion of someone and disregarding everything he says just because you disagree with one point. You have to take in the entire thing and then pick out the stuff that you think is valuable, okay? It's not as black and white as it seems. There's always some truths and some stuff that you think, well, no, that's fine.
When you actually run through your performance, what you usually want to do then is each arena has an initial allocation size that you usually tune to try and make it so that it doesn't have to really do growing very often, right? Because anytime you've got this system in place, you get another huge bonus, which is allocation is like very cheap. It's like one check and one add to like move the thing forward, right? So you can also get a huge speed boost by then just looking and saying how big should these arenas be in general and setting their initial sizes to that, because then you also don't hit the actual allocator.
Yeah, that's what I do. I just make them big enough so I don't run out of space.
Let's say I want to push some dynamic amount of data and I run out of space. The calling code expects n bytes and will write n bytes, but I don't have n bytes. How do you handle this case in that style? You've got 2 choices. So one choice is that you actually write your code to look at what comes back and handle it, right? And that's still the n class way. I usually do that though, and the reason for that is because it's usually actually not that hard to do, right? I tend to check those things anyway, but...
Strawman argument? I don't think it is, to be honest. It's an argument, bro.
You can decide not to do that. What you can do, if you'd like, is you can just return a ring mapping. So similar to what happens in when you call mmap on Linux, where it just maps the same 4K page repeated like forever. So then you can just return a pointer to that page and people can read and write to it for the rest of time and they'll never crash. But they also didn't actually do anything. So that's a good option if you literally, like, if you really just want to go, look, I want to handle any failure cases here, but I also don't want to introduce any overhead into the code or possible mistakes because a lot of people are going to be using variable size things. I don't want them to have to test anything. That almost never happens. It's really rare because most things aren't variably sized. So that's why I usually just return a stub that you write to. But if it's really, truly variably sized, right, you can just return a repeat mapped page. Which is a stub for arbitrary sizes.
ZII. Everything is 0 by default. 0 is always an accepted value.
So the way that I do stub stuff is I use what I call 0 as initialization. So it's like RAII but good.
Okay, so let's make our own idea. So let's say if that is +2, right? If we go into the game and we call spawn enemy, this returns me an enemy pointer. So oftentimes I do spawn enemy and then I check, well, did I get an enemy back? What if we can't spawn an enemy? By his idea, 0 is a good idea. So I would have to return the null pointer here, correct? And so I cannot add the enemy because it doesn't return me a proper index. I would have to check this here, you know, is the index unequal to an invalid index? Then 0 is an accepted value and I return null pointer. I think he's saying you always have a dummy entity that's always valid. I didn't catch the context though. Yeah, so the dummy entity could be returning this static memory here. And the reason why this is static for me, by the way, is because entity is very large. And if I put it on the stack, I'm running out of stack space. So I'm putting it in the static memory. While yes, that's a bit slow and annoying, it also makes me not run out of stack space. So that's why it's static. I could have this be a dummy entity on the game state in the heap memory. That could be a 2. But I put it here. So yeah, I could return this essentially. True. It's just not gonna spawn an enemy then, and then I would probably have to toss in like a warning, right? Or maybe like an assertion. But the program would still run. It just wouldn't spawn an enemy, which I don't know. I think I'd rather hard crash here because then I notice it immediately. That's his n+2 essentially. Okay, 0 is always an accepted value. Same, I don't like this at all. Yeah, I don't like this either. I don't know if this is like
Zero's
+2.
initialization just means that memory is 0 by default, which is true anyway. Any memory you get from the operating system is 0 by default. You have to be like on an embedded system or something before that's not true. But for security concerns on Windows, Mac, Linux, whatever, the memory you get back is 0.
Pop-up screen download.
So the way that I
more
handle
RAM.
stubs is all code is written so that 0 is the default case, which means that you can always return a stub, which is just a block of zeros. So you just have a stub in memory that's a block of zeros, and anytime something fails, you just return that one instead. Then when the person actually reads to it, or reads from it, or writes from it, it just doesn't do anything. And then at the end, you just clear it. Right? At the end of the frame, you just clear it. Or every time you're going to go hand it out again, you clear it.
Yeah, so essentially, instead of returning a null pointer here, it would be essentially like this stub, which I guess that would be like a memory that is full of 0. Not a null pointer, but that's actually like that would be then decasted to an entity pointer. And then it returns us a 0 entity. You could essentially do like this still here. You're writing to the stub at this point. But then that's cleared to next frame and it's gone. Yeah, you could still do this because you have the stub memory. Obviously, the stub has to be big enough then. But yeah, he's only talking about memory. And earlier today, we talked about the use case when we have a file handle. To sum it up a little bit, what the argument was is we either write or read a file. Potentially this here could fail, the fwrite could fail, and therefore we still have an open file and try to write to it, but it didn't work. Therefore, let's say the assertion hit or it exited out early and the fclose on the file handle never happened. And a good way to get around that is to have a class using RAII where it would always make sure that you fopen the file and then close the handle. My argument, counter argument for this is to use defer together with a macro. So instead of creating a class for this, which is optional, you can do that, and it's a good point to bring up, right? You would always make sure that you close the handle and you make sure that you free it so that others can write from the file or read from the file, write to the file or read from the file. But you could also create a defer statement that always gets executed when you run out of scope, and then you create a macro that says read file, and it puts the defer statement right below the write file or read file call, and then whenever you run out of scope, it still happens. So there is a potential way around this that is still correct. It doesn't require you to clean up after yourself. And so at this point for me, the RAI statement is valid. It makes sense, but it's not required. We're talking about being required here. You got that right? You can write your own defer with RAI, that's kind of cool. Yeah, you can do multiple things, true. And I think that's the beauty, right? You don't have to do it this way, but you can. File handling is one of the situations where goto is handy for always doing cleanup, whether you jump to it explicitly or execute it manually. Yeah, anyways, so that's my point. I like the n+1 here. The n+2 is a little bit wonky for me. I don't know if that's a good idea to do or not, but it's optional, right? In situations where you always need to have back memory, maybe returning a stub is a good idea. But I think that's a very nice conversation to have, and yeah, I can't wait for the downvotes. See you next time. We have 45 comments on a video that has 700 views. So people have strong opinions, to say the least. I thought about reading some of the comments. This was painful to watch. You clearly have no clue what resource management means, yet you have the audacity to shout wrong like a child. I knew this was gonna happen. I'm not mad that people write this. That's totally fine, right? People can call me an idiot all they want. I don't. At the end of the day, it doesn't really matter to me, right? Who cares? You know, it's all about perspective and what you think is important or not. And so I love the discussion around this though, so that we have like an idea of what could potentially happen, right? And maybe improve. Clearly have no clue what resource management means. Yet you have the audacity to shout wrong like a child. I was waiting for these comments, you know, guys. It is not about memory allocation. He even literally showed you another example of resources with the file opening, not knowing why RAII is important, even outside memory allocations, makes you a beginner in C++, period. And then these people tell him to watch the video from a non-noob, Casey Muratori, smart pointers, RAII, ZII, becoming a N+2 programmer. I agree with you, but I'm just going to assume by the way he wrote the message that anything Casey will say in the video will fall on deaf ears. Ooh, this guy answered. Okay, guys, we have spawned a discussion here. Ooh, I'm aware with Casey video, but if you actually listen to his arguments, you will find that there are not any. He's just dogmatic and ignorant. Your arguments against Casey don't take... Wait, he claims without backing them up. Probably not the best idea to listen to a guy who has no gameplay in his game after 10 years, despite even taking money for it by making false promises. But you're missing the point. I'm talking how Cakez missed the entire point of RAII. Cheers. The guy that made the original video is actually the noob if he thinks that manual management is noob behavior. Like Cakez said, you manage memory in a way where you allocate one only or a few times memory arenas that keep the memory valid for different lifespan in the program for which you suballocate. That's actually the pro move. True. So here's one that I saw earlier on the toilet, and I want to make fun of this guy because he keeps making fun of me. Now read carefully with me, guys, okay? Because this guy is making fun of my English. This is from Inukai, aka Giga Forever on YouTube, whenever he writes a comment. Giga Forever is Inukai, guys. Okay? Alright, we should give him a downvote. I don't know / use it so it doesn't count. Is such a silly argument when you consider that my grandma would have 0 noob counter. With the same argument, knowing fundamental language features and the standard library are all part of knowing a language. Aha, are all. I wonder where he typed that. Must have been pre-typing this stuff. Even edited. This guy doesn't even edit out his errors. Very valid argument, I have to say. It's valid to not use them, but disregarding everything because of ignorance and not for actual reasons is unfortunately common with the C subset of C++ people. Also, you missed the point of like half of the things in the typical two-head behavior. Nails. Downvote. Toxic. I love this, you know. I love this. Good stuff. So this is what I... Oh my god. You do need templates? If you want the best performance, not using templates leads to this pattern of encoding generic data structures with void pointers for members with hack type safety. It's an additional allocation to an additional indirect memory reference hoop. Read. Potential cache miss. Unless, of course, you actually don't need those, but it depends on the domain. Why not define your own begin and end functions in your error? They are so easy to define. Yeah, I know. I should do that. You're right. Should do that. You're right. I'm lazy. You should do that. You're right. So look at these comment chains, man. It's a great video. I love this shit. You know what I found funny? There was one guy, or actually 2 guys. They were like, oh, let me subscribe here. And then they watched the video and they're like, nah, man, fuck this shit. And then another one was like, hell nah. The aesthetic move parts had me dying. Just use C at that point if you're not even using RAII and value semantics. Dead.